Hello and welcome back to Mikey's Flightdeck. Today I will show you how I have built this combined engine and oxygen panel for my aft overhead panel. Before we go into the construction, let me tell you that this section of the overhead panel is the first one that I have completely designed in Fusion 360, which helped me already to see if any of the components collide with each other or with the frame of the overhead panel. And this before I have made any cut with my laser. So this took me a little bit more time to learn a new workflow, but it already saved me some time on the other hand, which I would have wasted because of some design errors. And I can recommend to watch the end of this video too, where I go into some programming errors I have made in MobiFlight and ProSim and how you can avoid them. After all the acrylic pieces are cut out with a laser, I have given them a coat of paint, and now it comes to the engraving. And for all those of you who are new here on this channel, I want to say again, how do I engrave panels with a laser? You can't find the orientation of the piece on the sacrificial layer like on a CNC where you can touch the edges. A laser is just light, it can't touch anything. So how do I find the orientation? For this I use some scrap pieces of MDF and then laser the outline of the piece I want to engrave onto the MDF. Don't move the MDF piece then, and orientate the piece you want to engrave onto it between these lines. And then don't forget to set your focal length new to the top of the acrylic. This is 3 millimeters higher than the MDF you have engraved before. After this, start the engraving process and it engraves into the acrylic exactly where it has to be. For larger pieces that don't fit on one scrap piece, it doesn't matter that the piece is bigger. You can just take two of them, align them side by side and align the piece you want to engrave on top of them so that only the outsides here are on the MDFs. The middle isn't important, it's just important that you can do the right orientation here. If you don't want to use MDF, I have also seen people using paper, but make sure that the paper lays flat on top of your sacrificial layer of the laser. Don't move and don't cut through this paper, because then the paper again could move. First, a big on-off switch and a switch guard are installed. 15mm hex standoffs and some screws hold the different panel layers together. The bezel of the gauge is glued together and onto the panel. Because I was working so much in Fusion these days while I have planned the panel segments, I finally found a solution for a challenge I always have with my annunciators. I'm printing the annunciators out of two parts, an upper part and a bottom part here, because with this method I don't have to print any support structures for the top piece here. But I have to glue them together later and they have to be centered on top of each other. Before this, I have eyeballed the center and looked a little bit to the inside of the annunciator, but it was always very tricky and not always perfect. And finally now, when I'm more into this 3D thing again, I have built a little jig, which didn't cost me much time. It is based on the outside shapes of these two parts here. And it works like following. The top part clamps here into this jig, and after this the bottom part, spread with a little bit glue, comes into this shaft here. With a little bit of pressure, the two pieces come together and can be pushed through this jig. And then when it is glued together, then they will stick together and they come out perfectly centered. After preparing the 5 annunciator boxes, the labels and the LED holders are glued in place. Now let's come to the EEC button. This is made out of a bottom part here, a top part, an engraved label, a 12mm tactile button and 2 LEDs. The button will be mounted on the bottom of this bottom part here. There are holes in there where it can go through, and then you can solder it from the bottom side here. The top part here has a little hole in the middle, and this fits with the top of this button so that it can sit in here and don't move to the sides. There are some small notches here on both sides and also on the bottom part, and these notches here will prevent the piece from getting out here. When the overhead is hanging upside down, then it can't fall out. But there is enough play so that the bottom inside can be pushed. And the button can get out because it is held inside of this top part here. In the top part here there are 2 holes where the LEDs can be mounted in. There are also little holes where the wires can go through, and also here are holes where the wires can go in to be connected with the LEDs. And then at the end the label comes on top here. There was a problem I had with the first design of this EEC button. The 2 LEDs are placed in 2 separate chambers, but when I placed the label here on top, then light could still spread through this white acrylic sheet here and illuminate the other side. So when one LED goes on, the engraving on the other side could be illuminated too. And so I changed the design a little bit, not much. I raised the barrier between the 2 chambers up to the top here and divided the top plate into 2 engraved pieces here, which then will be set into these chambers here. And with this modification I have a complete separation of the 2 LED segments, and when one LED lights up, the other part still stays dark. To prevent the LEDs from sliding out of their holes, I secured them with a little bit of hot glue. The 2 unused legs of the button are secured with hot glue to give an additional hold. I applied a shared ground connection to come out with only one ground wire for the button and the two LEDs. The different levels of the gauge are connected with 40mm hex standoffs. And now we have a situation where the CNC is in front of the laser. And this is only a small application here, but important for the gauge of this panel. I have here this needle. You will see this in more detail in a second. And I have designed a rectangle around this needle. I have written down the measurements of this rectangle, and so I can put the needle, which is cut out, again into this rectangle here, and then touch it with the CNC, and so I know exactly how the needle is positioned on the CNC. And what do I want to do here now? I want to do an engraving with an exact depth and a clean surface at the bottom into the center of this needle so that I can place the rod inside. With a laser I can do something in this direction, but it wouldn't be safe that the bottom of this engraving would be flat, because I have said this to you, with a laser you only can control the depth by the power you give into the laser. With a CNC I can say exactly, I want this hole to be 1.8 millimeter deep, and it comes out 1.8 millimeter. So let's engrave a small hole. I think this will be a CNC job of 5 seconds. To ensure that the needle can reach all the positions here on the gauge, I have written 3 lines of code on this Arduino Uno, which just positions the servo at 90 degrees, which is the middle position. Then I align the needle to the middle position here, like this, and then I can move this gear here up to the gear on the servo motor and glue it in place. After all the hardware is finished, we now come to the configuration in MobiFlight and ProSim again. In MobiFlight, I have used now my new Arduino I. There are not many inputs here, 3, which are the 2 EEC buttons and the 1 passenger oxygen button. And I have declared some output configurations here. Most of them are LEDs, and one of them is the servo motor for the gauge. If you want to know how the configuration of a device in MobiFlight is made in detail, watch my video number 35. I will lead you to every step of the configuration. Now let's go over to ProSim. There we find the needed configurations in config, configuration, and the combined config tab. And here in the engine category, you find on the switches the 2 EEC buttons I have used. I only used the push state of these switches. There are also these latches. You have seen this maybe on some photos, these clear covers of these switches, which I haven't modeled here in my panel. So I only need the 2 push state. There are also the offsets declared. And under indicators, you find all the LEDs that I have configured here. For example, again, the EEC buttons, the 2 LEDs, and the engine and reversal LEDs. Now there's only the gauge missing, and for this you can just insert Oxy here in the search bar, and we can see there are only in the pneumatic section some values here, and on the gauges there is the one we are looking for, the oxygen pressure gauge. I have declared an 8-bit offset, and I will use the full offset for this gauge. Everything you have to do is to move the sliders so that the needle meets these 5 key values. I have opened the panel here in ProSim displays so we can compare the values on my hardware panel with the values in the software. I have prepared running in the background, and I have connected the panel to the Arduino and to a 5-volt power supply. And when I now click Run in MobiFlight, then we can see the needle jumping to its position. And now let's test the LEDs by just clicking here on these annunciators in the software. So reverse of 1 works, 2 works, engine control left works, and right works too. And passenger oxy on works too. Now let's come to the switch here. There it is opened, and when we close it, it closes too. Now last thing, the push buttons, EC right. It is pushed and the alternate light is on, and left pushed and alternate light is going on, and now off again. Everything works. I haven't found out how I can illuminate these on lights here. They are working, but maybe you can post me just a comment how I can test these lights here in the software. And now at the end, let's come to the promised failure solution and prevention. When I tested my panel the first time on the Arduino, then most of the right LEDs here were lighted up. The on EEC light was on, and here these 3 LEDs, and the passenger oxygen button was flipped up, which is really curious because it should be closed at the beginning. So, and now I search for the reason of this. This can be a bad soldering point on the Arduino, a not working pin, for example, a hardware failure in the LED or the switch. But it was really curious that all these buttons together and these lights had a failure. So this couldn't be the reason for this. And so I thought there must be something in the software that isn't configured right. And so it was. Let me show what it was. I thought I am documenting really good here so that I can follow up where all the offsets are used. But still not good enough. Here you can see the two EEC buttons, left and right, and they are using the 66 EC offset, like many others. For example, like the LEDs, which also had a malfunction. At the moment of this failure, I had used another offset. I come to this now. This offset I had used at this time was also used up here in the electronic panel. Here we are now up in the Excel sheet at the electric panel configuration, and especially at the 7-segment displays of this. You can see most of the time I'm using 8-bit offsets and I'm using full offsets because you need a full offset for a 7-segment display. And when I use a full offset, I always write down a dash behind here so that I don't come into trouble and inserting any hex values. But here you can see these two segment displays are a 16-bit type. And this means they use two full offsets. I have written down the first two offsets, 66ED and 66EF, for example, but I haven't written down the second offset that every one of this is using, 66EE and F1. And because of these two offsets missing in my documentation, I searched for it when I made the new configuration and thought, okay, fine, there are two offsets that are not used until now, so I can use them now. And now the same offset is used in two different configurations. Whether MobiFlight nor ProSim will inform you about this problem, or if there is an option, I haven't found it until now, but there can be scenarios where the same offset should be used in different configurations, so this isn't always a failure. But it can get you into really deep trouble when you aren't aware of the fact that you are using the same offset for a second time. So now I will also write down all the offsets here that are used by a configuration so that it is documented and I don't run into such a trouble again. So when you run into trouble that LEDs light up or a button don't behave like it should, then maybe you should search for a multiple used offset first. And again, a next section is completed for my DIY overhead panel. 3 last holes have to be filled before I have completed a fully working overhead panel. So if you don't want to miss this upcoming episode, don't forget to subscribe to my channel to stay informed about any upcoming new video from me. So I hope we'll see you soon back on the flight deck.